Hi, welcome to section 6.5. What we're going to be doing is combining like a little bit more information together from what we did last time to try to smooth out the edges and make sure that we understand everything that's going on. Particular important thing is this reference angle, which I mentioned in the last video. So, a quick reminder of when we are dealing with these 30, 60, 90 right triangles. We really like it when we make the hypotenuse of that triangle equal to 1. And we can do that according to our trig ratios by just dividing everything by 2 or by 2x. In order to make all of these sides, this side equal to 1. It messes up these two sides, but it messes them up in a good way. Sine ends up being this value right here because it's just going to be this side divided by 1, so it's not going to change anything. Cosine ends up being just the value right here. So cosine ends up being just 1/2 for that thing. Oh, dang it. So cosine ends up being 1/2. And then tangent is the 2 divided by each other. Yeah. If we move on to tangent, tangent is just the 2 of those things divided by each other. So the important takeaway from right here is that sine ends up being the y value, and cosine is the x value, and they're at least connected to it. If you can make this a 1, then it's exactly sine is going to be the y value, and cosine is going to be the x value. But there's definitely a strong relationship between sine and our y values, and cosine and our x values. Now what we can do with that is we can look at the whole coordinate plane and we can figure out what sort of values we're going to get from sine, cosine, and tangent in each quadrant. So here, all of our y values are positive, so sine has to be positive. Here, all of our x values in quadrant 1 are positive, so cosine has got to be positive. Tangent is these two divided by each other. So positive divided by positive is definitely positive. So everybody here is positive. When we get to quadrant 2, the x value becomes negative. So cosine is some negative value. What that negative value is, I don't know, but I definitely know it's negative. Sine is going to be positive because we're still going up in terms of y. If you divide a positive by a negative, you get a negative value. So sine is the only thing in this quadrant being positive. You can continue this theory down into this quadrant. We're going down in the y-axis and negative in the x-axis, so those are both negative. A negative divided by a negative is a positive, so this is tangent, t. Tangent is the only thing that's positive here. And then in the final quadrant, by all the logic that we've been doing up to this point, cosine is the only thing positive. So first quadrant, they are all positive. Second quadrant, sine is the only thing that's positive. In the third quadrant, tangent's the only thing that's positive. And in the fourth quadrant, cosine is the only value that will, it's the only ratio that will spit out a positive value. So a phrase to keep this straight is all students take calculus. All positive, sine's positive, tangent's positive, cosine is positive, calculus. There's another one, all senators talk crap. The book uses ax, but that goes clockwise instead of counterclockwise, so I don't really like X. If you want to, you can make up your own phrase that goes ASTC, whatever you want, in order to keep straight who's positive in which quadrants. I need you to know who's positive in what quadrants, but what sort of phrase you want to use, it's up to you. So we'll look at little riddles kind of like this. We want a quadrant where cosine is negative and sine is positive. So if I think about that, all students take calculus. I need to know where cosine is negative. So I know that cosine is positive in the first quadrant because everybody's positive there. In fact, let's do sine. So here sine is positive, and here sine is positive. In the third quadrant, cosine is negative. In the fourth quadrant, cosine is positive. Cosine is also negative here, since in the second quadrant, sine is the only one that's positive. So here's the thing that we're looking for, where sine is positive and cosine is negative. So this would be quadrant 2. Neat. Where is cotangent and cosine both positive? So cotangent is the reciprocal of tangent. And the reciprocal functions follow the same pattern that sine, cosine, and tangent are. So if you think about all students take calculus, where is cosine going to be positive? Cosine is going to be positive in the first quadrant and the fourth quadrant, because they're all positive in the first one, and cosine is positive in the fourth one. All students take calculus. Cotangent is related to tangent. So tangent's positive here, so cotangent will be positive here. And tangent, all students take tangent. Cotangent will be positive here. So where they're both positive is right here in quadrant 1. Where is cotangent going to be negative? Well, that's going to be the opposite of what we just did. So cotangent will be negative here and negative here. Where is cosecant going to be positive? Cosecant is the reciprocal of sine. So sine is positive. We did that up here in these two quadrants. So cosecant will be positive here, and cosecant will be positive here. There's the thing that we're looking for. It's quadrant 2 again. Note that I'm using Roman numerals for your quadrants. Please always use Roman numerals when talking about quadrants. I will mark it wrong if you use Arabic numbers, like if you use Q2. I will mark that wrong. We want to use Roman numerals. All right, so now we're going to solve kind of a little equation. Now, note in this thing, I don't care what the angle is. Could not care less. I don't want to know that. I want to know what the cosine of the angle is. That's all I want. I don't know what. I don't care what the angle is. Just want the cosine of that angle. Now, they've given me some information. I know tangent. Well, what is tangent? Tangent is opposite over adjacent. So I know inside of my triangle, my opposite side is going to be -5, and my adjacent side is going to be 12. I also know that my angle is in quadrant 2. So if I draw my angle, here's the positive part of it. We're moving on into quadrant 2. So I know I've got a triangle right there. I want to connect that to the x-axis, because remember, that's how coordinate points work, connecting it to the x-axis. So here's my reference angle right in there. Opposite side is -5, and my adjacent side is 12. I want to figure out what cosine is. So cosine of theta is the opposite side. Ooh, I know what that is. I'm sorry, it's the adjacent side. Ooh, I know what that is. It's 12 over my hypotenuse. Oh, shoot. I don't know what that is. Well, that's easy. I can do a Pythagorean theorem. So -5 squared plus 12 squared equals my r squared, because for some reason I'm using r. So that is, r squared is 169. So r is plus or minus 13. We're always using the positive value for those r's, so it's going to be 12 over 13. All set. Neat. Isn't that kind of neat, where you get little puzzle pieces? So you identify the quadrant, done. Oh, that's opposite and adjacent. Who am I missing? Oh, I just need the hypotenuse. If they had asked me for cotangent, I could have just flipped this thing and been done. One little thing I missed, though, note my coordinate point here. This doesn't make any sense. This is not +12. That's going to the left. So that is -12. And then note how this thing is going up. That's not a negative direction, so this is a +5. See how you can kind of tell where that positive and negative should go? So my actual answer is -12/13, which makes way more sense, because if we remember, all students take calculus, I know I should get a negative value in this quadrant for cosine, because sine is the only thing that's positive here. Let's see, we've got secant is -13/5, and my angle is in quadrant 2. I want to find cosecant. Well, based on this, I know that cosine of my angle is going to be negative 5/13. And I know I'm going to be in quadrant 2. So let's draw my angle in quadrant 2. I'm going to start right here and go into quadrant 2. Now that I've drawn my angle, I need to fill in my side lengths. So cosine is negative 5/13. But does that negative go with the 5 or the 13? Well, cosine is adjacent over hypotenuse. Oh, well, that makes it easy because the hypotenuse is always positive. So the adjacent side must be negative, which makes sense because we're going in the negative direction on that x-axis. I'm looking to find out cosecant. So I know cosecant is the reciprocal of sine. So it is going to be the hypotenuse over the opposite side. Oh, I don't know the opposite side. Dang it. Well, that's okay. I can do a little Pythagorean theoreming. So I've got 13 squared. Here, actually, let's do this over here. 13 squared equals negative 5 squared plus my y value squared, because it's the y value, so why not use y? So that's 169 equals 25 plus y squared. So subtract 25. So 144 equals y squared. Square root, we get plus or minus 12 equals y. Ooh, now which one are we going to use? Are we going to use the positive case or the negative case? Well, we've got to go up. And if we're going up, that is a positive direction for y. So I do want to use the positive case. Now, if it had been down and we were in quadrant 3, I would have used negative 12 and not positive 12. Now that we know our opposite side is 12, we're just going to write that in, which makes sense because this is a positive value, and we know sine should have a positive value in quadrant 2. Let's do another one. So this one is going to be in quadrant 4. So let me draw my angle here real quick. Whoop, whoop. So we're down here in quadrant 4. So here's my theta. And here's that reference angle thing. We're going to see that defined very soon. We want to figure out, okay, well, cosine is going to be adjacent over hypotenuse. So adjacent and hypotenuse. Let me draw a right triangle here, connecting it to the x-axis. My adjacent side is going to be 40, and my hypotenuse is going to be 41. All I need to figure out for tangent is I need to know what the opposite over adjacent is. Oh, I don't know the opposite side. I know adjacent. I know it's 40. Here's our adjacent side, but I don't know what this opposite side is over here. Well, that's okay. I can just do a little Pythagorean theorem. So 41 squared equals 40 squared plus y squared. So I'm just going to do this on my calculator here. So 41 squared minus 40 squared, I got 81. Oh, it's a nice Pythagorean triple. 81 equals y squared. So we square root both sides. We get plus or minus 9 equals y. Now, hang on. Do I want to use the positive case or the negative case? Well, hey, this thing's going down. And if it's going down, that's a negative direction. So I want to use negative 9 for my y value. So tangent is going to be negative 9/40, which makes sense. All students take calculus. In this quadrant, I should get a negative value for tangent. That's what I got. Nice.